right. Hello, and welcome to another episode of the Better Brain Fitness Podcast. I am Josh Turknet, and I am joined, as usual, by my attentive co host, Dr. Tommy Wood. Hello, Tommy.
Hello.
It's becoming like a game for our listeners to figure out the connection between our adjective and the topic or the topic. um, so it's been a little bit since we've done one of these, finally getting back on track. And today we have a question that actually we got from two people almost back to back.
Mm.
So we figured we'd tackle it. The first one came from Bill from Denver, who asked, "What do you think of the recent paper, Effects of Computerized Cognitive Training on Vesicular Acetylcholine Transport Levels Using Positron Emission Tomography in Healthy Older Adults?" It was published in September of 2025, so just recently. Can computer game training really increase my acetylcholine production like that of someone 10 years younger? What role does acetylcholine play in my brain? So, great questions. And then Dennis from Ohio also asked about that study. He said, "I've been using the drills at Brain HQ for a few years. I see there's a recent study at McGill University, which is the one I just mentioned, that showed measurable increases in cholinergic activity after just 10 weeks of using the drills versus a recreational computer game. The difficulty with this field has always been one, establishing an effective control activity so that we can tell if these drills are just the same as spending time and energy and awareness on your mental health. This study seems to be a better example of a control. Two, are the changes lasting and do they translate to improvements in memory and attention and so forth? I have been using these drills plus supplements. Can you elaborate on the difficulty of properly evaluating these types of brain improvements? This would seem to tie into your last episode, indeed it does, which talked about much more sophisticated and time dependent testing for cognition. So, very nice, detailed, thoughtful questions there on this new, recently published paper uh, on the effects of the particular type of brain training on the brain and using kind of a novel method for evaluating it. So, um, Tommy's going to first take the first stab at kind of telling us about the paper, what it shows, what it does not show, and maybe the takeaways that we can get from it. So, Tommy, it's all yours.
Thanks, and thanks for these questions. Really good, and clearly people are paying attention to to what we're saying on the podcast, which is nice because they're right that trying to study cognitive enhancement is really tricky, especially with these online platforms, because we don't know whether getting better at a test or some kind of training program makes you better at the other things that you actually care about, right? And we only would think about all the different ways that we might train the brain or enhance cognitive function, if it's helping us go out into the world and have more focus, better attention, better executive function, better decision making, better working memory, or memory in general. So this was a nice study that we'll go through, and it's actually a very interesting. It's not a formal follow up, but it does progress the research beyond probably what is still the best ever cognitive training study, the active study that I'm not
Mm-hmm.
sure that we've talked about extensively on the podcast. But it uses a similar training paradigm, or the sort of the more recent version of the same training paradigm, which is now built into the Brain HQ training platform. And the results do sort of line up quite nicely. So, and we'll talk about both, because I think that kind of relates a little bit to the question about, is this long lasting? Because this trial, only looked a few months out, but what we care about is, what does it look like years down
Right.
the line? So what they did in this study is they relied on a relatively new PET method to measure cholinergic signaling in the front of the brain, the anterior cingulate cortex in particular, although they looked throughout the brain. And this is important because the the cholinergic signaling from the forebrain is very critical for memory encoding. It's very critical for attention. It's a big part of the salience network in the brain. And this is something that's lost as we age, with mild cognitive impairment and in dementia patients. That's why cholinesterase inhibitors like galantamine are used in individuals with Alzheimer's, because that increases the amount of acetylcholine that's in the synapse, so that you can sort of help to maintain some cholinergic signaling. It doesn't treat the cause, but it does, help manage some of the symptoms. And in general, the number that they quote in the paper is that once you get into your 60s and older, you lose about 2.5% of your cholinergic signaling in those regions of the brain per year. So what they did is they took older adults. I think on average they were in their early 70s, sort of 71, 72. And they randomized them to 10 weeks of cognitive function training, either with the active intervention, which was 2 different brain training games or platforms from Brain HQ. The first one being Double Decision, and the other one being something called Freeze Frame. So Double Decision is this: you sort of have to identify things on an image whilst trying to detect an object in the periphery of the image. So this is something that has a significant time component, and it's essentially supposed to be a speed of processing training. So like both of the training components that were used in this study in the intervention had a significant time component, to try and improve speed of processing, right? Where it's really time dependent. And then the control group were these sort of more like just like traditional games we might play on a computer or on our phone, like something similar to Candy Crush, Solitaire, something like that. So very similar to, we've talked about activities that Gloria Mark might call rote activities. They require some focus, but they're not really cognitively demanding or cognitively challenging. So there's no sort of time pressure. There's no sort of drive to have to process information quickly. And they had them do this for 35 training sessions over 10 weeks. It basically ended up being an average of about 30 minutes a day for 10 weeks. And then they looked at signaling with a PET scan before and after training. They also looked at cognitive function using a cognitive battery, the NIH Examiner battery. And they also did some simpler cognitive function testing, like you would do if you're being screened for MCR, like using the MOCA test. And what they saw was that in the intervention group, there was a significant increase in cholinergic signaling in this part of the brain that they were particularly interested in. And this was not seen in the control group. So the control group stayed pretty stable, whereas there was an increase in signaling in the intervention group. And the amount of improvement they saw on average was about the same as the average decline you might see in a year, in an individual sort of this age. So potentially sort of helping to stabilize cholinergic signaling, at least over this period of time. There was a significant increase, but you're maybe even offsetting more than what you would have lost. So this is probably one of the first times where they've done a really good job of looking at some of the core biology or physiology, biochemistry that we think is underlying some of these training processes. Because before, you would just like do the test, do some training, do the test again. It's very difficult then to separate out learning effects from the tests themselves, which we've talked about before. Or are you just getting better at the training itself? And they did show that the participants in the intervention group were better at the 2 training games than the control group when they sort of tested them at regular intervals, as you would expect. But then they also saw something particularly interesting, which was that in the intervention group, in those who had a lower cognitive function to start with, so at the bottom half in terms of the formal cognitive testing, they seem to get greater improvements in cognitive function associated with the intervention than those who are sort of above that level. So, but the improvement in cholinergic signaling was seen across the entire group. Although the distribution of some of the changes of cholinergic signaling was actually different based on sort of where people started from. So all of this to kind of say that in terms of what you can measure from a formal cognitive test, if you're already doing okay, doing this kind of thing, you might not see much of an improvement because you're already doing okay. Like you're not going to improve that much on it. But in terms of the formal testing, but there may still be an improvement in the underlying biology that could help sort of long term. And then for those who are already experiencing some decline, they may see significant benefits in some of these formal cognitive tests, may be more likely to experience some improvement sort of out as they go about their daily lives. Although that wasn't assessed here. There was no assessment of, are you functioning better out in the real world, which again can be hard to measure, but would be a useful output for this kind of thing. So potential benefit across the full range of starting cognitive functions, but maybe in slightly different places. It does look like the results were sort of stable another 3 months out. They had like another assessment point, and without any further intervention, and things held relatively stable. So some of this does seem to sort of to continue to be the case for long periods of time. So at least months after the end of the intervention. But that's really as much as we could say from this study. But very nice that they're doing, they had a good control group. They spent as much time in front of the computer. They did something that would have felt engaging, but wasn't truly challenging these sort of like the underlying biology here. And we sort of see results kind of suggest that there is a direct effect of this very specific type of training on some of these components that we know are susceptible to the aging process and susceptible to those as they experience mild cognitive impairment and dementia. So like certainly very like super promising. But to kind of think about longer term, I think this is where we go back to the active study. And if anybody's read the paper, they do reference the active study very heavily because this is still, even though the active study is now nearly 30 years old. It was published and started in the 90s. It's still probably the best example we have that cognitive training can improve, like meaningfully improve, like actual real world things. So what they did in the active study is they took nearly 3,000 adults, it's about 2,800 adults, older adults, again, sort of in that same age range, sort of mid 60s upwards, mainly in the 70s. And they randomized them to 4 groups. There was just a standard control group who didn't get any intervention. There was a speed of processing group. So they did that same, what is now double decision within BrainHQ. They did the earlier version of that, essentially the same thing, having to like focus on, like you have some distributed attention and you have to kind of focus on something on the periphery that flashes up quickly while you're kind of doing another task. And then there was a reasoning group, sort of like, kind of finding patterns in words and letters. And then there was a memory training group. But the memory training was more like giving people skills to help them remember things like mnemonics and that kind of stuff. So it wasn't like forcing people to remember stuff. It was kind of teaching them skills in order to be able to remember better. So when they looked several years out from the active study, and the training period was actually surprisingly short. It was just 6 weeks, and then they had refresher interventions at roughly 1 year and 3 years afterwards. And they sort of followed them out for 5-10 years at least. And they found that several years out from the training, from this relatively short period of training, all of the intervention groups had less of a decrease in overall like quality of life and ability to do sort of like day-to-day things compared to the control group. Although the benefits seem to be greatest in the speed of processing training group. The speed of processing training group and other papers from the same cohort were found to be more likely to drive, several years out from the training intervention, and less likely to be involved in car accidents where they were at fault. and it was a big enough study that they might actually have enough numbers to kind of look at some of this, although it's still a relatively rare intervention. So all the different training types seem to be beneficial for sort of like activities of daily living, but processing speed seems to be better in terms of keeping somebody doing complex tasks out in the real world, such as driving. And then the sort of like the final part of this is that a 10-year follow-up study found that those who were in this speed of processing training group had a significantly lower risk of dementia compared to the control group, and no benefit in terms of dementia from the other two training groups. So really, across that whole time span, multiple kind of signals that speed of processing training can meaningfully change activities of daily living and cognitive function and cognitive decline long term. I will say that these sort of longer term follow-up studies, they can be tricky because you lose a lot of people, you get lost to follow-up, people die for other reasons, this kind of stuff. So the study wasn't originally designed to look at dementia prevention, but it was a big enough cohort that they could kind of look for a signal. And like whenever they looked for something, they did seem to see that cognitively the speed of processing training group were doing better. So even with relatively short interventions, although relatively intensive during the period of training, with sort of intermittent brief periods of kind of refreshers with the training, there did seem to be some meaningful long-term effects. So while in general, I think we should be skeptical of these ideas of cognitive training because we're still trying to figure out what really moves the needle on that front. And probably most brain games aren't going to do the job because, like, here's solitaire and other things, they're fun to do and they can absolutely be a part of your day if you enjoy them, but they're not going to be really challenging your cognitive biology enough to make significant shifts there. But I think there is some evidence that when we're really forcing ourselves to improve function, particularly as it comes to focused attention and rapidly having to make decisions and process information, that seems to be a trainable skill. You can now measure changes in the brain as a result of that, and I think we have some pretty good data historically that this could translate into some benefits long term. So though both of our listeners were appropriately skeptical of this intervention, actually I feel pretty good that there's something here. Of course, I think it doesn't have, you don't have to sign up for Brain HQ and do this particular task, right? There are lots of different skills and things that we can engage with that require us to do the same thing. We've talked about open skills sports, we've talked about music, we've talked about all many other environments, dancing several times. We talked about the brain clocks study, right, which probably has some similar elements here with other video games, dancing, musical instruments. So I think a lot of that requires similar skills and requires similar processing. But if you want to add something to your arsenal, I think the right kind of brain training platform could certainly play a role there. So that's where I was at with this study and the sort of the history of it. Josh, any other thoughts, comments, questions, concerns?
Yeah, thanks for that breakdown. That was great. And the history with the active trial as well is super helpful to put it in context. And I think, one of the things here is that there are kind of the scientific implications of something like this and then the practical implications, and sometimes those can get intertwined, but there's the piece that, how does this fit in with our knowledge of what's happening in this scenario, and then there's the separate piece of what does this say about what we should be doing, right?
Yeah.
And along the first line, the cool thing about it is it gives us a little more information about what's actually happening. What is happening in the brain in the active trial or in other
Yeah.
types of cognitive training kind of interventions. And one thing that we've talked about in the past is the concept of cognitive reserve, which is often the thing that's been, the mechanism that's often used to explain how these things work, right? Is that when you're doing other types of cognitively stimulating activities, you are sort of building in excess capacity that can compensate, right, for deterioration in certain places. We've been kind of, talking about the other view, which, Michael Merznick was the first person for me who was like beating this drum and still is, but
And
how this
he was the founder of Brain HQ.
exactly,
Yeah.
exactly, right, right. So he would say that this is not reserved. This is you're restoring, right? You are restoring the deteriorating parts of the brain. So, and that's what we're seeing here is these systems that we're talking about that are deteriorating, that we know to be deteriorating. The cholinergic system are responding to this intervention, and what this the cool thing about this one is it's showing an increase in the capacity of that system. So the density of the cholinergic terminals is increasing based on the imaging, which can't tell you for sure if that means more circulating acetylcholine, but we presumably, that means the system has responded by increasing its capacity, which is super cool, and is kind of plasticity in action. So also supporting that these types of things are restorative rather than just building out reserve that can compensate for decline and deterioration. I think the practical aspects of this, what part of what the issue is when you're trying to advance the science, you have to do what you can test in a lab, right? So you have to do it under a certain set of constraints, right? And this happens in all sorts of fields, nutrition and exercise, right? You have to do some rigid protocol that in order to gather good data, in order to be able to know that you're, what the effects of your intervention. That doesn't mean that thing is the best thing to do. It just means what is something you're testing in order to figure out what's going on. And what you can rigorously test is rarely going to be what's going to work best in the real world. The challenge is always then how much do you extrapolate? Right? How much do you have to? Some people are super adherent. Oh, you can only just claim what's been tested in an experimental setting. Other people would say, it's proof of principle, and then you can expand from there. And I think that I'd fall in. Let's expand from there. And I think that generally, the more broadly stimulating anything is, the more intense it is, the greater the effect. So in general, real world complex learning is going to be the ideal scenario for cognitive stimulation. That's not to say that other things can't work, and we see benefit here. The question is, for something like this, how much does it translate into real world, effects? And we don't know that for sure. But we clearly have evidence that it's having a biological effect, which is super, super encouraging. I think that, if you look at like what the difference between the intervention group and the control group and what they were doing, and if you just look at the whole body of research, I think for me, kind of the most helpful organizing principle is this thing I'm doing driving some degree of plasticity, right? These people are, one group, they're doing an app or a game that's really kind of drawing upon skills they already have and are kind of just using them and like you said, like the kind of the rote type of tasks, where you're not necessarily improving from one session to the next, versus something where you are things are changing over time, and so anything that's kind of driving that, where you can, there's some evidence of progress, and then sort of the more complex, the more systems that are involved, likely the greater that effect, right?
Yeah.
The other question I had was, given that we have this, tool now for measuring cholinergic transmission, I'd be super curious to know what's happening. So you mentioned that the medications that are primarily used for Alzheimer's dementia these days are the cholinesterase inhibitors, which help to increase the amount of acetylcholine in the synaptic cleft. You wouldn't be surprising if you see downregulation in the capacity of the system with that, right? We see that with pretty much every drug that acts on the nervous system. So I'd be very curious to know what's happening to the capacity of the system in cholinesterase inhibitors. And if I had to hypothesize, I would predict it actually would go down. Not something you want, but in that scenario, you were just dealing with the best that you could. Whereas here we have something that's actually increasing the capacity of the system. So much from you're actually addressing the fundamental issue in a much more direct way and not potentially undermining the problem with your solution. Um, so that I would love to see that study. I don't know if anybody's going to do it, but it would also be interesting just to like, you know, the control task, was something fairly mindless. Like, what are all the various tasks that would, is it
Yeah.
really is anything that's going to have some learning element to it? And I think that's, again, that's what I would say is the biggest organizing principle is if you're learning something right from one time to the next, which means you're likely driving some degree of plasticity. I think those are the things that are most likely going to be helpful. Um, all right, I think those were the things that I wanted to add. Um, I do. Was there like a battery that these subjects also got that was like a of like executive function as a trying as a proxy for real world benefit? I thought
Yeah.
I
So
remembered that.
yeah. So they did. They did a cognitive battery, like one of the the NIH
Right.
examiner, which include which covers a range of different cognitive function. I think they mainly looked at the just like the composites of all these different things, and they saw particularly in those who were at the lower
Those are the
end
one. Okay.
initially. So like they had to not have MCI, right?
Mm-hmm.
Clinically diagnosed cognitive impairment was an exclusion criterion, but those who were at the lower end of cognitive function to start with saw
Right.
some benefits in terms of these sort of like global cognitive composites, which usually include various aspects of executive function, working memory, that kind of stuff.
Right. Yeah, I think there probably were people in the trial that weren't technically MCI but were below expected for age, and
Yeah.
maybe headed that way. Um, all right. Well, good. That was good. Great questions there from both of those listeners. Anything else you had to add?
No, I don't think so. I think
Okay.
that's a good summary and a very nice. I thought it was a very nice study. Kind of helps build the evidence there in terms of like just adding to the range of different interventions we might have in our toolkit, depending on the kind of things we might like to do.
Right. Yeah, and exciting evidence of the mechanism of what's happening. Um, All right. Well, thank you, Bill and Dennis, for your questions. If you guys have any follow-ups related to this topic or any other questions around brain health and fitness, feel free to send it our way. You can comment on our Substack. You can click on the link in the podcast description, or you can go to brainjoe.academy/questions and ask it there. And we will add it to our database. All right. Thank you all for listening. Thanks, Tommy, for the breakdown.
Thanks, everybody, and we'll see you next time.
All right. Bye-bye.